Hello data lovers, so welcome back to the SQL Interview Pro series, and today also I am going to solve 4 SQL interview questions. And for last 2 videos I'm pretty sure you guys have watched it and solved all those questions. If not, then check it right now and solve those questions immediately. And the questions which I will be solving today, you can find it on Code Studio platform by Coding Ninja, and these questions are free to access, so completely free for you to practice SQL question. I have provided the link in the video description. Like this video for the better reach, because I will be covering some amazing topics of SQL today. First, try to attempt these questions by your own, put your solution in the comment section, and then watch my solution. So let's start now and solve today's SQL question. This is our first problem, and the problem name is all valid triplets that can represent a country. So we have a table school A. It has 2 columns: student ID, student name. So each row of this table contains the name and ID of the students in school A. All student name are distinct. There is same table like school B. There is same table like school C. There is a country with 3 schools where each student is enrolled in exactly 1 school. The country is joining a competition and wants to select 1 student from each school to represent the country, such that member A is selected from school A, member B from school B, member C from school C. The selected student's name and IDs are pair-wise distinct. That means no 2 students share the same name and no 2 students share the same ID. Write a SQL query to find all the possible triplets representing the country under the given constraint. So if we look at this data, we have school A, school B, school C. So it is like in the school A, all the students will be distinct, right? In a particular school, right? The student names, all these things will be student, but with the same name, right? And even the common IDs, because more than 1 person can have the same name. So this data can be in school B and even in school C, right? Different schools, same persons, right? Different persons with the same name can even take the admissions in these kind of schools. So we actually need to create the triplets of the students from each of the schools, right? We need to pick 1 student from each of the schools and we will call it a valid triplet. So if you look at the resultant output, this is a valid triplet because it is not following this condition. That means any of the students, member A, B, C, do not have the common name. Also, they do not have the common IDs, right? So this is the constraint we need to take care while considering this part and joining this data. And for the more detailed explanation, you can read it, how this particular result is being generated. So how we can solve this problem statement, and I'm pretty sure many of you have already got the idea how we can solve it. Simple trick is the joining, right? And here it is all about basically all possible kind of triplets. So when it comes to all possible pairs, obviously inner join, left join, right join, outer join kind of thing will not help us here. We need to perform a full cross join, means all the elements from one table should get joined with all the elements of the second table. So that is the kind of cross join we need to apply, and after that we will apply the where clause to take care of these conditions. So let's start writing this part and select. So from, let's say, school A, we want the name. From school B, we want the name. From school C, we want the name. So I will name it like A dot student name, as it will be named like the member A, member underscore capital A. And now I will copy it, A, B, and this is C. We will name it like the member B, member C. So this is the final output we need to print from school A, right? This is the data we need, school A, and we will give the alias name like A, cross join right? In the cross join, obviously we don't need to provide any condition. The whole row from this table A will completely get joined with all other rows of the table B. So cross join with school B, cross join school C, and here we need to apply the where condition, and the where condition is very simple. The student name from the school A should not be equivalent to the B and C. So how we can write it? A dot student name not in these two values, right? It shouldn't be equal to any of these two values, right? So this is for one element, right? A is not equivalent to B and C. Like how you generally check a number is distinct. If you have given three numbers, you will check, okay, A is not equals to B and C, but there is a possibility that B and C can be equal to each other. So we need to eliminate that part as well. So we will write it like, and B dot student name not in, or for this single comparison you can even apply the not equality condition, right? So this is how the first condition we have applied, and same kind of rule we need to write for the IDs as well, right? Because ID also need to follow the same kind of condition. So student name will be replaced with student ID. This is there, this is there, this is there. Okay. So student ID, student ID, student ID everywhere. And now if we execute it, then we can see this is the expected output we were looking for. So in this row, right, if we verify the output, right, so Ellis, Tom, Jerry, then Bob, Tom, Ellis, and this was the expected output. So let's move on to the next question. So this is our next question, and here it is median employee salary. So the employee table holds all employees. The employee table has three columns: employee ID, and these employees can belong to different companies, and their salary. Write a SQL query to find the median salary of each company. Bonus points if you can solve it without using any built-in SQL function. So this should be our final output. So this is a pure mathematical question, and I'm pretty sure many of you already know how to even calculate the median if you have given some numbers. If not, I will quickly tell you how to do that. Let's say we have given this kind of number. So list of number, basically this is total odd numbers, right? 1, 2, 3, 4, 5, right? Odd number list. And similarly, let's say there is a list of elements which are not arranged, let's say 8. So this is even number list. So in order to find the median, right, from the given list of numbers, what we need to do first, we need to sort them in the ascending order or the descending order, right? So if we sort this list, it will become 2, 3, 5, 6, 10. So in the case of odd number, so the total length is what? Total length is n equals to 5, right? This is the total length of this number list. So in case of odd one, if you want to find the median elements or the element which will be the median from this entire list, so it should be n plus 1, right? N plus 1 divided by 2. All right. So ultimately the median index or the element which will be the median from this list, it will be 6 divided by 2, and we can say third, means third element from this list after arranging it in the ascending or descending order. So 5 will be the median element. Let's talk about this one, the second, where the list is even. So for this one, right, it will become 8, 10. So in case of the even length, right, in case of the even length, so how we can even calculate it? Basically, it will be there will be two elements which will be the median, right? So this one, right? Fifth and sixth. So what is the index for it? The index for fifth element is 3 and the index for sixth element is the fourth, right? So how this will be calculated? Then it will be like two numbers, median elements n by 2 comma n by 2 plus 1. So n by 2 means 3, n by 2 plus 1 means 4. So these two elements, fifth and sixth, will be the median elements. So that is how I just refresh your memories. So this is exactly we need to solve here, and we can see, let's say this is for the company wise. Actually we need to do this exercise, right? For each company, what we need to do, write a SQL query to find median salary of each company, right? So for this company, if you can see 1 2 3 4 5 6 total 6 salary elements we have been given. So obviously in the final output we can see 2 employee IDs, right, which were lying in the median values. For company B, again 1 2 3 4 5 6. So this is how we can see 2 outputs in the final you can say result following this part. And now if we look at the C, 1 2 3 4 5, so odd number, that's why only one median element we can see here. So let's solve it, and for this one again we will follow one fundamental, how to basically get these median elements. So we will be using the window function here, and that is the row number. First, what we will do, we will arrange our salary data in the ascending order, right? In the partition by, first of all we will use company as a partition key, and salary and ID columns in the order by. One, the row number will be used where salary and ID are ordered by in the ascending order. Second column will be derived where this will be in the descending order. And then I will show you that trick, how without even using the mathematical functions we are calculating those median output rows. So let's write that query first. So select star comma row number over partition by company order by salary ascending comma ID ascending, and we will name it like as num, or we can say rank something, rank ascending. So this is the one column we have derived. Now same thing we need to derive, and we will name it like descending, DESC, and we will descending, right? From which table? From the employee table, right? Now if I execute this thing, then you will see the actual magic, right? So here we can see this is how our data is looking like. Now focus on the output. So for company A, right, we need 5 ID 5 and 6 in the output, right? That is how we will get it. So in order to get these two median elements, right, because now we have arranged our data, right? Even previously I explained, in order to find the medians from the number list, you need to arrange them in the ascending or descending order. So you can see our salaries part are actually arranged in this manner. So after arranging it in the ascending or descending order, the list of number is even. So these two elements will be the median rows, or these two rows we need to print here. So here how to actually calculate it. So idea is very simple. If you look at the ascending generated rank and descending generated rank, so if you try to filter out records based on the condition where this rank should lie between 1 plus and 1 minus of the descending row, then mathematically we can get this one. How? So let me complete this query, and here what we need to do, we need to print it without using any. So looks like the order is, or final print order is this salary one, right? The final printed order should be in the descending value of the salary. So let me first complete it and then I will explain this part. So select ID, comma, company, comma, salary from this table, and we will name it like TMP. And what kind of where condition I was talking about? Where TMP dot rank ascending between rank descending +1 and -1. Also order by company name, comma, salary. Everything will be in the ascending. So just focus on this where clause. Here what we are checking, rank ASC. Just focus on this one. This rank is not between +1 value of this and -1. So if you do the -1, it will become 0. So right, so if I write it in this way, 6, 1. So here 6 is being compared with what? 6. So if you add +1 and -1, so it will in this one, so it will become 0, 2, and 6 is definitely not between the 0, 2. So same thing you can apply till this point, but focus on this point. So idea is, right, if you have few numbers and if you arrange them and provide them some ranking in the ascending and descending order, then the middle elements ranking will definitely clash with each other, right? So the best example is this one. Focus on this part. If we arrange it in the ascending order, generated the rank, and descending order and generated the rank, then here what we can see, this median element, which is 3, right, the ranking is actually clashing. So that is the advantage we are taking here. So if you focus on this one, right, we want to pick it up in our final output. Here rank ascending is 4 and rank descending is 3. So if you add +1 in it, so it will become 4, and -1 it will become 2. So 4 definitely between 2, 4 if we do the inclusion part. So that is how this condition is matching, and same for this one, right? If you add +1 in 4, it will become 5. If you do -1, it will become 3. So 3 is obviously between the 3, 5 here. So that is how it is being calculated. Now if I execute this complete part, oh, looks like 0 output. What's the mistake here in this condition? Okay, so I think first I have given the upper bound limit and then the lower bound limit. That's why it is failing. So I need to change it. This should be the upper bound and this should be the, this should be the lower bound and this should be the upper bound. Now if I execute it, yes, so we can see the output, and this was our expected one, right? A, B, B, C, and these were the values which we were expecting in our final output. So I hope now you got the idea. It was simple mathematics and we just played around with the row numbers part. And why we had to actually do it, because it was written if we can solve it without any using the built-in function. So that's why we had to do those kind of tricks. If you first want to try it with the simple, you can say with the simple inbuilt functions, you can do that. But I like this question. I think you will also enjoy it while solving it. Cool. Let's move on to the third question. And here, this is our third question. The problem statement, get the second most recent activity. So this is the table we have, user activity. This table does not contain primary key. Here we have 4 columns, username, activity, start date, end date. So a person with username performed an activity from start date to end date. Write an SQL query to show the second most recent activity of each user. If the user only has one activity, return that one. a user can't perform more than one activity at the same time. So what we can say here, for any user, whatever activities it was doing, no two activities, start date and end date, can overlap with each other. So if we look at this data, here we can see this was the username, and from this date to this date, it was doing the activity travel. Then from this date to this date, it was doing dancing. Then again from this date to this date, travel. For Bob, it only did the one activity. So if we focus the main SQL query, here we need to show the second most recent activity. So if you focus for the 𝗟𝗟𝗃, so the latest activity done by 𝗟𝗟𝗃 will be this one, because this is the start date, which is maximum. It means this was the most recent. So what will be the second most recent? One less than this one. So this is the start date, and this is also the second most recent date. So that is why in the output we can see we have included this one, dancing 𝗟𝗟𝗃, this record as a second most recent activity done by 𝗟𝗟𝗃. But for Bob, as we can see right from the condition, if user has only done one activity, then we only need to return that one, right? We will not be able to check that most recent one. This will be the most recent one. So that is how we need to write the query. And again, this one truly very simple to solve here. We will be using the window functions, right? One for the counting as well, and another will be for generating the ranking based on the start date in order to get the second most recent activity. So let me first write that inner subquery part. Select star comma, here what we need to do, select star comma count. This is the, we need to use activity over partition by username, right? This is just for counting, like how many activities a particular user did, so that we can tackle this kind of situation where only one activity was done. So that is why we have generated as total activities, right? And now if we copy it from here, we copied it, and now we will use another one, row number, right? Row number, and simple partition by username, order by start date, descending as rank, right? From which table? User activity. So now if I execute it, so because of the UI constraint, we will not be able to see this complete output, but our data has been generated. We can see the final output here. And for the final output, what we are going to do, we are going to select these three columns, which is the username, right? Username, comma, start date, comma, we need to include the activity as well, activity, comma, start date, comma, end date, from, right, this table, and we will name it like TMP. And here in the where clause, we need to check for this part. First we will look into this, if rank was generated, right? So first condition, we will check if second most recent activity exists. So we will simply include that one, right? So for this one, what we can do, where rank equals to 2. So for example, if this condition was failed, what will happen? That means there was no more than one record, right? So this is failing. What we need to check, or this total activities less than 2, right? So this is the condition we need to check. And now if we execute it, right, we can see this was the expected output as well. ls dancing, this was the start date, end date, and the result for the Bob. So that is how this was, I would say, simple to solve. It was just we had to play around the conditioning, how to deal only one activity kind of record, and if there are more than one, then how to generate this number based on the ordering of date with the help of the window functions. So this is our last question for the day. Find the quiet students in all exam. So this is the student table, student ID, student name, and this is the exam table. Exam ID, student ID, score, where exam ID, student ID is the primary key for this table. A quiet student is the one who took at least one exam and did not score neither the high score nor the low score. So write an SQL query to report the students, means the student ID name, being quiet in all exams, right? Being quiet in all exams. Don't return the student who has never taken any exam. Return the result table ordered by student ID. So I think you have got the definition of the quiet student. That means the student is the one who took at least one exam, and didn't score neither the high score nor the low score in that particular exam. So let's verify it and understand it from the example. Here we can see this is the student ID 1, 2, 3, 4, 5, Daniel, Jade, Stella, Jonathan, Will. And this is the exam, right? So different exams will be there, right? Exam ID 10, 20, 30, 40. So here what we can see for this exam, right? Exam ID 10, right? So what was the maximum score? Maximum score was 90, minimum score was 70. So this student 2 actually scored 80, which is neither the high score, neither the low score. And even this student appeared in this exam, so it is following this condition, means appearing in at least one exam and not even scoring the high score or the low score. So let's try to understand from the explanation that how this student is actually coming in the final result as a quiet student. But again, you can read the definition. Quiet student is someone who did not even score the highest and the lowest mark and appeared in at least one exam. So what we need to do, SQL query to report students being quiet in all exams, means whatever exams they appeared, they were quiet in all the exams. It shouldn't be like that particular student given 5 exams and in 4 exams he did not score the lowest marks or even the highest marks, but in one exam, right, he scored the highest marks. So that student will not be considered as a quiet student, because quiet in all exams. If it appeared in 5 exams, he should not score the lowest and the highest marks in any of those exams, right? So that is how we can verify. So for exam 10, student 1 and 3 hold the highest and the lowest, right? 70, 90, but student 2 scored 80. So for this exam, we can see student 2 was the quiet, right? For exam 20, only one student was there which scored the 80 marks, which is the highest and the lowest. So obviously this student will not be considered at all for the quiet student, because he scored the maximum minimum in either way. For exam 30, student ID 1, 4 scored the maximum minimum, and here 3 was the quiet student, but we will not consider it quiet, right? Because in this exam 10, he scored the highest marks. Now for the exam 40, student ID 1 scored 60, which was the lowest. Student 4 scored 80, which was the highest. But this student 2, which scored 70, and even in this exam, this student 2 was the quiet or the silent one. So this student 2, right, it is actually following the proper condition of being quiet in all of the exams. That is why we are getting it in the final result. So let's try to complete this query. So how are we gonna solve it? We will solve it in 2 parts. In the first part, we will calculate those student IDs which scored the highest or lowest marks, right, in any of the exams, right? In any of the exams, if they score the highest and the lowest marks, we are going to consider them in the sub query, that these are the students who cannot become the part of that quiet student group, or they cannot, or they are not even eligible to be the quiet student, because in any of the exam they scored the lowest or the highest marks. What we need to do, select, right, and here distinct student ID from exam table. Join means it will be the inner join, and here inside we need to write or derive something like this with the help of the union all condition. Means for each exam ID we want the minimum marks and the maximum marks. So that is what we need to generate here. So if you look at this part, select exam ID comma minimum score as score from exam table and group by exam ID union all. We will do it for the max, right? Here max score from exam group by this one, and we will name it like TMP, and join condition will be E dot exam ID equals to TMP dot exam ID, and same goes for the score as well. So this way we will be able to find these kind of students. So if I simply put the star here, right, you will be able to see the intermediate output, how it looks like. Let me execute it. So here, this is how you can see. So this was the exam ID, let's say exam ID 10, and student 1 and 3 you can eventually see who scored the either maximum or minimum part. Similarly for this exam 21, student 1 who actually scored the minimum or maximum score. For exam 30, 1 and 4 scored the maximum minimum score. For exam 40, 1 and 4 scored the maximum minimum score. And here we will only worry about the student ID. That's why we were taking the distinct student ID, right? So now this part is done. If you can see, so these were the distinct IDs we have got, and after calculating this intermediate data, we will write the outer subquery, and this intermediate output is giving us those students who even scored the maximum or minimum part. So the outer query, it will simply do the lookup part, means where student ID not in, means those students who are not part of this calculated data will be the one who were quiet in all of the exams. So select distinct student ID comma student name from student table. We will name it as ST. Join exam table as EX where student ID. But before this we need to write the on condition, and this joining will happen on the student ID key. So on st dot student ID equals to EX dot student ID, where EX dot student ID not in this part, this group. We will enclose it as TMP1 and order by this value student ID in the ascending order. So now if we execute it, can I remove it? Okay, so it should be ST, because ambiguous output it will be multiple references. Alright, so now we got it correct, and this was the expected output we were looking at, because this was the student who was quiet in all of the exams. So these were the total 4 questions from the hard category which we solved today, and I hope you would have enjoyed all these 4 questions. And my personal favorite was the second question, the median related thing, and also this one was also good. So let me know your opinion and follow the same approach, solve it by your own, put your solution in the comment section, and also let me know in the comment section which question did you enjoy the most while solving. And I will see you guys really soon with the next part of SQL Interview Pro series. Until then, keep liking these videos so that it can reach to maximum number of people. Also keep exploring data.